それでは続いてシンガポールからお招きしました皆様に発表していただきたいと思います。タイトルが Synthesis of Photocatalytic Iron Fumarate Metal Organic Framework Microrods for the Degradation of Organic Dyes Hwa Chong Institution からリャン・シャオジュンさん、リュウ・ウェイションさんです。どうぞステージへお越しください。ご指導いただきましたのはゾウ・ヨークキョウ先生です。それではよろしくお願いいたします。
Good afternoon, distinguished guests, ladies and gentlemen. I am Sao Jun. This is Wei Sheng, and we are the presenters from Hwa Chong Institution, Singapore. Today, we'll be presenting about our project entitled The Synthesis of Iron-3 Fumarate MOF for the Degradation of Organic Dyes. Firstly, allow us to make a brief introduction about Singapore and our school, Hwa Chong.
Singapore is one of the smallest countries in Southeast Asia, located north of Indonesia and south of Malaysia. Singapore is known as the Little Red Dot because Singapore is very small, only 15% larger than Tokyo. In addition, Singapore is also known as the Garden City. It preserves nature within the city, having nature parks such as Gardens by the Bay.
Next, an introduction of our school. Hwa Chong Institution is a high school in Singapore that was founded in 1919, making HCI 100 years old this year. Our school has a combined junior and senior high school, so we can advance to senior high directly without needing to take the national exams.
Now, let us move on to our project. Up to 200,000 tons of dyes are being dumped into water bodies annually, most of which are highly toxic and chemically stable. Photocatalysis, or the generation of highly reactive, non-selective radicals under light that can degrade organic dyes, has high efficiency and is less toxic. However, it has its own disadvantages, as commercial photocatalysts such as zinc oxide has a narrow band gap. Hence, we believe that improvements can be made to this method. Metal organic frameworks, MOFs, are a class of metal-organic hybrid materials. Not only can most MOFs be created using simple and cheap methods, but they are also porous, hence having a large surface area, making them highly efficient as photocatalysts. In comparison with the other reported MOF photocatalysts, Iron-3 Fumarate MOF is cheaper, has lower reaction durations, and is easier to synthesize. Thus, Iron-3 Fumarate MOF has great potential to be used as a photocatalyst. Hence, the objectives of our project are to synthesize Iron-3 Fumarate MOF using Iron-3 chloride and fumaric acid. We intend to compare the effectiveness of our MOF with that of commercial photocatalysts such as zinc oxide and titanium dioxide. Next, we would like to determine the effectiveness of our MOF in degrading organic dyes such as brilliant green, metallic blue, and methyl orange. Last but not least, we would like to study the effects of different amounts of MOF and hydrogen peroxide, as well as the presence of lights on degradation. These are the dyes that we have used in our experiments. Moving on to the synthesis of our MOF. Iron-3 microride and fumarate acid was mixed together and heated at 100 degrees Celsius for 2 hours. The mixture was then centrifuged to obtain the precipitate. And then the precipitate was washed and dried. This is the SEM results for the MOF that we have obtained. MOF obtained has a structure of hexagonal microrods. As previous researchers have also obtained iron 3 fumarate MOF as hexagonal microrods, we can hence conclude that we have indeed synthesized iron 3 fumarate MOF.
Moving on to our degradation studies. To investigate the effect of visible light on the effectiveness of the degradation of dye, MOF is added into the dye solution and stirred for a day with or without the presence of light. The control setup does not contain any MOF or hydrogen peroxide. Our final dye concentration is then measured using the UV-vis spectrophotometer at various wavelengths. The following equation is then used to calculate the remaining final concentration of dye. The results of the test is shown in the graph above. From the graph, we can conclude that the presence of visible light enhances the ability of our MOF to degrade all 3 dyes. The effect of the presence of hydrogen peroxide on the degradation of dyes shown in the graph above. Iron 3 fumarate MOF with hydrogen peroxide is the most effective in degrading the 3 dyes. As iron 3 fumarate MOF is a photocatalyst, under visible light, electrons will be promoted from the valence band to the conduction band, which reduces other molecules. The electron holes formed by the promotion of electrons acts as an oxidizing agent, and together they can take part in redox reactions to generate radicals which degrade the dyes. Hydrogen peroxide is one of the precursors to the radicals, which is why both hydrogen peroxide and light enhances the effectiveness of our MOF in degrading dyes. A similar setup is used with the above parameters using zinc oxide and titanium dioxide. Based on our results, we can conclude that iron 3 fumarate MOF is very effective in breaking down all 3 dyes. Interestingly, our MOF is more effective than both zinc oxide and titanium dioxide in degrading our The average band gap of our MOF is determined to be 1.5 electron volts, which is lower than that of zinc oxide and titanium dioxide. The size of the band gap determines the energy of light required to start the reaction. With a low band gap, light in the visible light and near-infrared range can start a reaction. So there is a higher percentage of photons in the visible light range that can start the reaction, making our MOF more efficient than commercial photocatalysts in harnessing visible light. Above shows the mass spectra of the degradation residues of metal orange when hydrogen peroxide was added. Considering the masses of the degraded products, it is proposed that demethylation, desulfonation, and deamination occurred when hydroxy radicals reacted with the dimethylamino, sulfonate, and amine groups respectively. Notably, the azo group was broken down when a hydroxy radical reacted with the azo group to give either a hydrochloric acid or a nitro group, which shows that our MOF has the potential to break down persistent azo compounds like methyl orange.
Based on our results, we can conclude that iron 3 fumarate MOF can be synthesized using iron 3 chloride and fumaric acid. We can also conclude that the effectiveness of our MOF in degrading dyes is enhanced by both the presence of visible light and hydrogen peroxide. Last but not least, iron 3 fumarate MOF is more effective than commercial photocatalysts in degrading methyl orange, methylene blue, and brilliant green dyes. Hence, our objectives are achieved and our MOF is proven to be a promising alternative to commercial photocatalysts that can degrade organic dyes.
We would like to express our sincerest gratitude to the organizers of the 2019 Grand Contest of Chemistry and our school for giving us the opportunity to be here. We would also like to thank our mentor, Mrs. So, for her invaluable advice and dedication. Here are our references. Thank you.
ありがとうございました。それでは、質問の時間へと移らせていただきます。何かお聞きになりたいこと、ご質問などございましたら、挙手をお願いいたします。ご質問は、はい。では、マイクをお持ちいたします。お願いいたします。
Thank you very much. Very nice talk. Very, very nice talk. You produced the iron 3 fumarate MOF, right?
Yep.
If you use the iron 2 fumarate and to make a MOF, what will you expect to the activity?
Using the reason why we use iron 3 fumarate MOF is because so basically, the valency of the iron 3 ions is 3 plus in our MOF. So basically, to have a formation of our MOF, we will require the valency of the iron to be 3 plus in order for the organic ligand that we are using, which is fumaric acid, onto the 3 plus ion in order to form the required MOF structure. Hence, this is the reason why we use iron 3 as the central metal ion for our MOF.
Have you actually tried the using of iron 2 instead of iron 3?
No, we have not tried it. Yes, but the thing is, we require the iron 3. We require the iron ion to have a valency of 3 in order to have the MOF, the overall MOF structure. So I don't believe that using iron 2 would have a similar structure, will form an MOF with a similar structure.
Yeah, actually, if you use the iron 3, the MOF is more stable.
Yeah.
Okay, and another question, is okay? You use the trans structure fumarate, okay? It's the part of organic framework. If you use the cis compound, what do you do? What do you expect?
Using the cis form of our MOF, I believe we have a similar, somewhat similar, we will have obtained somewhat similar results, but we have not tried it using the actual experimental procedure. So I believe that can be a part of our future work also, to try the cis form of our MOF.
Okay, thanks.
Thank you very much.
ありがとうございます。それではお時間も参りましたので、以上とさせていただきたいと思います。シンガポールからお越しいただきましたリャン・シャオジュンさん、ユー・ウェイションさんでした。ありがとうございました。